Good morning to all. In today's session, we are going to start with the 10th standard chemistry and physics. Unit 9, electrical current series number 7 is going to be discussed. Earlier, we completed about how the current is originated and what are the units and how can we measure that current, potential difference, electromotive force, the activity based on that electrical current and potential difference, laboratory activity. All these topics were discussed. And even Ohm's law, what is the significance of Ohm's law in our daily life? How can we derive that Ohm's law is also completed. In addition to all these, unit number 1 to unit number 8, entire detailed explanation of this academic textbook topics were posted on the channel called World of Competitive Chemistry. Now we entered into series number 7, where we are going to discuss about the detailed description how the electrical shocks are possible under certain circumstances, and what could be the reason some of the birds are some of the creatures like birds are not getting any electrical shocks even they are on high voltage circuits. So we are going to discuss in detail about these topics. Let us enter into our today's topic, series number 7. Right. What is electrical shock? What causes electrical shock in the human body? Current or voltage, which is influencing when we are in contact with the electrical circuit or electrical connection with directly. Let us assume that human body is a resistor. We are not supposed to allow the movement of current through our body. So let us assume we are the resisting material. The resistance of the human body generally varies 100 ohms if the body is wet under conditions, and 5 lakhs of ohms if the skin is completely dry in nature. So this is the resistance. If high resistance is there, lesser will be the conductance. Even the current is allowed to pass through us, we are not supposed to pass that. So that extent of resistance. If under wet condition, so that is ranges, that is extremely low resistance and high conductivity will be there. That is possible under wet conditions. If we are in direct contact with moisture, water, any insulating materials are not equipped with us, in that condition it will be very less. Resistance is less, nothing but high, prone for this electrical shock. And if completely dry conditions are there in our surroundings and even in our body, if fluids are extremely low, at that condition, resistance offered by the human body is extremely large, around 5 lakhs ohms will be possible. So here optimum conditions may be in the range of 100 to 5 lakhs ohms. Let us calculate the amount of current what flows through the human body. So if current allowed to pass through the human body, then how it shows the effect and what kind of consequences we will face. We will discuss about this one. Let us see what causes electrical shock in the human body. Let us assume that if we have touched 2 electrodes of battery, which are consisting 24 volts of current and with the dry fingers, such a way that circuit is completed. Let our body resistance is 1 lakh ohms, for example. At that condition, this is a human body and it is possessing the resistance of 1 lakh ohms, extremely large. So our human body is enough to resist this passive current through us. We are taking 2 electrodes under dry conditions. The condition must be dry, and both are equipped with the 24 volts of current, and they are in direct contact with this human body. For example, what causes the electrical shock? Let us see. Then the current flowing through the body is given with I is equal to 24 by 1 lakh. 24 means what? 24 volts of current is offered from the external electrodes, and the body is showing the resistance, that is 1 lakh. Then here electrical current strength is given by 24 volts by 1 lakh. That will become 0.00024 amperes. Strength of the current is 0.00024 amperes. This is infinitesimally small. The after decimal point, you can observe 1, 2, 3, 4th digit will be there. This is almost negligible. Even this extent of current is passing at this resistance condition, that will not cause any current shock conditions in the human body, and no effect will be observed, being it is highly infinitesimal in nature. When such a small current passes through the human being, it does not affect the functioning of any organs inside the body, and it will not show any impact on us. Now let us see, do you know the voltage of mains that we are using at our household conditions? So for various purposes, we are using household electrical current which is passing through the wires. Then how extent of voltage is required for household applications? That depends upon the type of applications we are having, and that also depends upon the region where we are applying. And in much of the world, a voltage nominally 230 volts of frequency and 50 hertz is used. Here, voltage is nothing but potential difference required is 230 and frequency required is 50 hertz. So this combination is required in general all across the world. In North America, most commonly, combination of 120 volts and 60 hertz of power is being consumed. Other combinations, you may take 230 volts and 60 hertz. These are the various frequently used combinations for the household applications of electricity. So it is required to pass the potential difference at the frequency of a particular quantized mentioned parameter. So in this manner, different kind of conditions may apply for the household purpose. What happens our body if we touch a live wire of 240 volts? So earlier we saw only 24 volts of current, that is almost negligible, and the resistance offered by the human body is extremely large. At that condition, we are not suffering with any kind of adverse impact. But now what we are doing, extremely high voltage we are applying, that is 240 volts of current is going to be applied in the human body. The current passing through the human body, we touch the live wire of 240 volts and the resistance offered, let us assume that is similar 1 lakh. Now what happens? So if one of the decimal increased in the numerator, it will become 0.0024 amperes. So when there's quantified, this current flows through the body and functioning organs inside the body get disturbed. When this extent of high voltage is supposed to pass through the human body, so whatever organs are there inside our body having regular routine functions of them, and they get disturbed some extent. If some period, only fraction of seconds, if you are under the influence of that extent of voltage, this disturbance inside the body left causes electrical shocks. Sudden jerking is possible because we are applying high voltage for very short span of time. If the current flow continues, if we are continuing the flow of current further, it damages the tissues, because this extent of high voltage and exposure for the longer time, that may causes the tissue damage within the body, that will leads to the resistance of body will be lowered. If resistance of the body get lowered, what happens? Free flow of electricity is possible through the body, and the longer time of exposure of this extent of current, that is 240 volts of current, that resistance of human body still decreased further, and it shows the adverse impact on the heart functioning. It is the main tool in order to supply the continuous oxygenated blood to each and every organ. Then only here proper functioning of all the organs are possible in general. Then if a current reaches 0.07 amperes, at that condition heart functioning will become extremely low. High adverse impact will be present on this heart functioning, and it may causes highly chronic impact on this. That will become highly hazardous if this extent of current and high voltage is applied. So it will be continued, that able to kill that person who is exposed for the longer time this extent of voltage and even 0.07 amperes of current. So this electrical current shows the very adverse effect, and the impact of electrical current and voltage on the human body are summarized in this table. If you are applying the current in amperes, 0.001 amperes, the effect is almost negligible, being it is extremely infinitesimal value can be felt. You can experience how extent you are facing the electrical shock. If we are taking 0.005 amperes of current is able to pass through your body, that will become a painful experience. And the next, we are increasing the intensity of the current, that is 0.01 amperes. At the conditions, involuntary muscle contraction is possible. Muscles are first impacted by this electrical shock, so that muscle contraction. Muscles are the main organs which used for the mobility of human beings. For all kind of applications, relaxed muscles are required. But by this electrical shock, all muscles get contracted and they are not in the proper movement. If it is extended to 0.015 amperes of the current, it causes loss of muscle control. So muscle control are totally lost, so that here functioning of human body will become disordered. And we are still increasing the intensity to the higher extent. Just now we discussed that is 0.07 amperes of current. At that instant, the main organs, the primary organs which are driving our human being, like a heart, that will its function is completely disrupted, and probably fatal current lost for more than 1 second. So here heart functioning becomes difficult, and it may cause the high hazardous impact on the human being survival as well. Now, from the above discussion, we can conclude that electrical shock can be experienced when there is a potential difference exists between one part of the body and to the another part. When current flows through the human body, it chooses the path where the low resistance is offered. The resistance of the body not uniform in all across the body, right? Higher the resistance, what happens, lesser will be the higher the resistance offered by the human body, and most effective to discard this electrical shock. So that kind of effect is exerted, and all the organs are not exhibiting this extent of uniformity. Some of the parts suffering high resistance, some other allowing the passage of current through them because they are being associated with high extent of fluid content, like sodium, calcium, potassium, chloride, fluoride. All these are present in our human body. And if such a kind of ions are there, they are freely moving current from one region to another, so that resistance upward at that instance will be less, and that prone for the high risk of electrical shock. Now, for example, skin offers more resistance because it is the protecting layer. It used to give the high protection from all kind of external adverse circumstances, whatever present. It will protect us from bacteria, virus, heat, cold, everything used to resisted by the skin in the similar manner. Electrical shock conditions also resisted by this skin because it is not much associated with the fluid content and high resistant and low risk of electrical shock with this, so that it will protect us from this electrical shock when compared to other organs. So among all the organs in the human body, high resistance offered by the external largest organ in the human body called the skin. As long as current flow continues inside the body, current and resistance of the human body goes on changing inversely. Initially, human body is showing its own insulating mechanism, its own defending mechanism will be there, right? So if current flow is continuous in nature, what happens? If current flow intensity is moving in this direction gradually, then resistance is moving in the backward drop, because current flow is reciprocal to the resistance. As long as current passage is possible, resistance of the human body is slowly descending down and becoming highly extremely low condition, so that here adverse impact by the electrical shock will become high. Now, it is the condition, electrical shock is the combination of three factors, hence we can say it is a combined effect on the human body. One will be a potential difference, which is offered by the external circuit, how extent of EMF or voltage is supplied. So that is called the potential difference. And electrical current, that is the strength of the current measured in the amperes. How extent of current is passed. 0.07 is the extremely toxic or hazardous extent of effect, which show the high impact on the human activities. And another is resistance offered by the human organisms. So different organs having different extent of resistance. Highest resistance offered by the largest organ called the skin, right? So these three factors are playing how extent the person is influenced by the electrical shock when he is in contact with the electrical short circuit. Why doesn't a bird get a shock when it stands on the high voltage wire? So if you are touching that electrical wire, that causes a high extent of impact on us. But when that free moving birds sitting on that electrical high voltage wire, even they are not facing any kind of adverse effect. What could be the reason for that one? Birds can sit on the power lines, not get the electrical shocks, because electricity always looking for way to get the ground. The birds are not touching the ground anyway. That's the reason why they are not suffered with this electrical shock, because they are not making any circuit among them. So always we require a circuit. Birds are not creating any circuit, but human being is attached with the roots of the ground. Because of that reason, here always current tends to enter into the ground because of gravitational force. So that's the reason why man will experience the electrical shock when he is touching this high voltage, while rather the bird, even it is sitting on the wire, it will not impact any extent, because circuit will not be completed at that instance. Circuit formation is not possible, but human being is used to give the circuit because he is touching with the ground. So ground having high extent of gravitational force, and that tends to get the high potential, so that potential will travel through the human being into the earth. So he is becoming a conductor for that reason. Here he experience electrical shock. There are two parallel transition lines on the electrical pole. A potential difference between the two lines are taken as the 240 volts, which is extremely large voltage throughout their lengths. If you connect any conducting device across the two wires, it causes a current to flow between the wires. We are taking electrical poles which are supposed to connected with the two electrical wires, and the potential difference afforded by these electrical wires are 240 volts. So they are parallel to each other. Now, what we are doing, we are connecting both the wires. What happens? The current flow is possible across this connecting wire, right? So we are connecting with a current carrying wire, so that current passage is possible in the cross-sectional region. Now, if you connect any conducting device across the two parallel wires, it causes the current flow from one to another. The bird stands on high voltage wire. Even on this connected wire also, if bird is sitting, that will not show any impact, because no potential difference will transported through the legs of the bird, because it stands on the single wire rather than a two wires. That's why passage may not be possible. So no current passes through the bird, hence it doesn't feel any electrical shock. At this instance also, it will not face any adverse impact, because it is not standing on two wires at the same time. It only holding on the single wire, so that it will not cause any passage of current from one region to another, so that it will not impacted by the electrical shock. If you connect any conducting device across these two wires, it causes current to flow between the two wires. Bird stands on a high voltage wire, and no potential difference will be generated across that, so that bird will not affected by that electrical shock, and that is very safe in nature, because it is not connecting both the wires. So current passage may not be possible. Hence, it doesn't feel any electrical shock. And we completed how the electrical shock is possible, and what kind of parameters are influencing, and how extent impact will be possible by changing the voltage and even amperes too. So that kind of tabular representation comparative study have been completed, and what kind of factors influencing this kind of electrical shock is also completed, and exceptional condition for these birds, why they are not facing any electrical shock, being they are in direct contact with the high voltage wire. That fact is also discussed. Now we are going to discuss about some interesting fact regarding this multimeter. So multimeter denotes what? Digital multimeter denotes what? It having the functions of various measurements. So now we are going to discuss in detail about what is multimeter, and what kind of components which are present in this, and what kind of cautions we have to take in order to operate this safely. A multimeter is an electrical measuring instrument that combines the several measuring functions in a one unit. Single device used for the multiple application, then you can say it is a multimeter. Within the name itself, it showing that multimeter for the multiple applications. Digital multimeter displays the measured value in a numerals, direct digital. Means digits will be displayed on that. Multimeter has the three major components. The main components of this multimeter is the first one is called a display. A display is usually 4 digits and ability to display a negative sign as well, right? So here up to 4 digits, it conveniently measure the values. So it will show the parameters whichever required for us. You may want to get the electrical voltage, you may want to get the electrical strength, whatever kind of parameters you want to measure, that will be displayed on this display, right? And next is about selection knob. So here extend the range of resistance, the range of conductivity, the range of voltage, what you want to measure, that will be selected by using the selection knob. The selection knob allows the user to set the multimeter to read the different functions like milliamperes. If you want to measure the infinitesimal values, milli, so extremely low fractions of amperes you want to measure, that extent you can select using this knob. And a voltage, that is normal voltage or milli voltage, whatever kind of parameters you want to measure, that you can select. And also resistance can be taken into the consideration. So selection knob used to select what kind of parameters you want to operate. And next is about ports. Ports are nothing but external devices, connecting wires. So multimeter generally have 2 ports. One is usually labeled as COM, common or ground port. So this is a common port which is required. You may say it is a reference one. This is where a black test lead is connected. So black one is a ground port which is commonly used one. In either one is labeled as MAV. So here MAV ohm port where a red lead is conventionally plugged in. So this is in either port always. We require 2 ports in order to measure the various applications like voltage or amperes of current. Otherwise resistance, if you want to measure, all are applied, all are measured by using this digital multimeter. And we have one caution also. Most of the multimeters can measure alternative current quantities also, but alternative circuits can be dangerous in nature. So it is conveniently used for the measurements of direct current quantities in general. So DC current is generally measured by using this. AC current is also measured, but at the high risk of conditions. That's the reason why convenient for DC current only. That precaution we have to take so that it will be safe for the measurement of various applications, which is called a multimeter. DC current is mentioned in this manner. Direct current is flowing in one direction. Alternating current is having opposite possibilities. So in opposite direction, the movement is possible. So here AC current, some extent of high risk, we can observe, convenient for the direct current applications, right? By this work, we completed this session with how electrical shock is possible and what kind of parameters show the impact of electrical shock, and if we are varying the strength of the current, how extent of impact we can experience. All these were discussed in detail in the session. Hope this session will help for your preparation. Thank you very much for your consistent listening. Thank you one and all.